Hello class, welcome to everyone. In today's lab, today we're gonna discuss our lab number 3 in packet tracer, lab number 2.2.2.4, and it's about configuring IPv4 static and default routes. That's the lab we're going to do today first. And of course, we're gonna have breaks. I'm gonna discuss chapter 3, then I'm gonna take another break and come back to do the next lab, which is packet tracer configuring RIPv2. So we're going to be doing hopefully one lab first, then the chapter 3, and then again another lab. Okay, so let's get started. We're going to open up lab number 2.2.2.4. So let's go chapter 2. Lab number 2.2.2.4, 2.4, and here we are. For this lab, I'm going to open the packet tracer PKA file and also the instruction file, both of them. So let's open the packet tracer file. Here we are. Packet tracer, okay, cancel that. Okay, we have right here PKA file. Okay, then we're gonna also open up this instruction file. Well, I can open, that's not a problem, but I would prefer to have the other file, that is the this PDF file where I can actually type in some answers to some questions. So instead of this one, today I am going to open this PDF file, instruction file. Okay. And possibly okay. Maybe I could make it a little bigger. Okay, that much I can do. Okay. Here I am. So I hope that you all got these two files open. One, again, this is my packet tracer, and this is my instruction file in PDF. So I open the other file. Okay. So as opposed to instruction file right here, this is the typical instruction file that opens up. On this instruction file, I cannot type in. There are questions, but I cannot answer here. Therefore, I'm using this PDF file. Again, I'm just making sure and double checking and repeating, making sure all my students are understanding that I have two separate files open here. So let's read the instructions. Let's read the instruction first. And if every one of you, I see 5 viewers at the moment, if you all are hearing me correctly, if you all are understanding what I'm doing, I'm about to get started, just let me know, write a comment. I will know that you are watching me and everything is going okay. Okay, so here I am. Addressing table. In the beginning, let's understand the lab first. What the lab is telling us to do. Here is a router R1, another router R2, another R3. 3 routers and 3 PCs, PC1, PC2, PC3. Let's look at the topology. Logical topology. Here is R1, here is R2, here is R3. 3 routers are here, and 3 LANs are connected to these routers. In those LANs, we have each PC representing each of the LANs. Fine. I'm going to go to the options, make the font size bigger for you, as I always do. Helps you see better. Okay. Font number 16, apply. Well, that's a good size font there. Okay. Now, and what I see here, router R1 showing 2 interfaces, gigabit 00 and serial 00. I have their IP address and subnet mask. R2 showing 3 interfaces, 1 gigabit and 2 serial interfaces. R3 also showing two interfaces. So looking at the topology, here is R1. R1 has this gigabit 00 interface right here. I could go to the options and preference. In here, I could choose that always show port labels in logical workspace. I could do that right here. Always show port labels in logical workspace. I just checked on that one. So it's going to show the labels of the ports. Okay, I can do that. Okay. And here. So the labels are shown, but I cannot really see the label very well. Then what I do on my toolbar right here, see, it shows the serial interface and everything, but I don't know, it's a gigabit serial 00, serial 01, I don't quite get it. So I could click on this label icon right here, place note, that one, and I click on somewhere here. And that brings all the labels, okay? So now I can read them, okay? This R1 shows gigabit 00, that's the LAN. The LAN local area network is connected to that interface. And the serial 000 is connected to R2. R2 has serial 00, so both are serial 00 on this LAN from both routers. And here serial 001 from R2 and serial 001 from R3 are connected here. Then I have on R2 gigabit 00 interface is connected to the PC, which is the local LAN. Gigabit 00 always are connecting to the local LANs. Fine, I understood the ports. So at this time, I am gonna go ahead, or let's see, I can still see the IP addresses. You can still see the IP addresses, so that will be okay. So now, here, background. In this activity, you will configure static and default routes. A static route is a route that is entered manually by the network administrator to create a reliable and safe route. There are 4 different static routes that are used in this activity: a recursive static route, a directly attached static route, a fully specified static route, and a default route. Okay, we're going to learn all of those. What is a recursive static route? What is a directly attached static route? What is a fully specified static route? And what is a default route? I'm sure they will be asking us questions and we'll answer them. Part 1. Examine the network and evaluate the need for static routing. Okay, I'm in part 1. Looking at the topology diagram, how many networks are in total? So let's answer this question. Part 1A. Okay, let's see if there is any comment. Ryan, everything sounds good. Thank you, Ryan, for making the comment. Okay. Looking at the topology diagram, how many networks are there in total? So let's look at the topology right here. Here in my mouse, if you see my mouse right here. Okay, with R1, how many networks? This one network right here, gigabit 00. Another network is serial 00. That is one network. From these two router interfaces right here is one network. So total 2 networks so far. Total 2 networks so far. Then on the top here, there's one more with R2, 3. Then between R2 and R3, there's another network right here. That's number 4. And then with R3, we have one more network here. That's number 5. So altogether, 5 networks. So I'm going to say all networks are 5. That's my answer. Okay, I'm going to say 5 networks. I could just type FIV maybe. Okay. Okay. So how many networks are directly connected to R1, R2, and R3? Well, how many are directly connected to R1? Let's see. R1 has 2 directly connected networks. One is here. See my mouse. That is with gigabit 00. Another is with serial 000. So these 2 networks are directly connected to R1. So R1 has 2. R1 uh, R1 has 2, R2 has how many? Let's see R2. Here's my R2. The R2 network has, this is one network right here, another network right here, and then on the top gigabit 00, one more network. So R2 has 3 network connected. Here is one with serial 00, here is one with serial 01, and here is one with gigabit 00. So R2 has 3 network directly connected. And R3 has how many? R3 has with serial 001, 1, and with gigabit 00, one more, that's LAN. So 2 networks. Okay, good. I was able to answer that. Okay, how many static routes are required by each router? How many static routes are required by each router to reach networks that are not directly connected? Okay, so now I need to find out how many networks are not directly connected with R1. So R1 needs how many static routes? R1 needs how many are not directly connected? So R1 has 2 directly connected, this one with gigabit 00, one with serial 000. So 2 networks are directly connected. So how many are remote, not directly connected? 3 more. So we know that this one right here, this one right here, and this one right here. So total 5 networks. So 2 are directly connected. So 3 are remote network that are not directly connected. Those remote networks would need the static route. So R1 needs 3 static routes. 3 static routes. Then R2 needs R2. I see R2 has 3 directly connected, so 2 are remote for the R2. R2 has these 3 networks, gigabit 00, serial 00, these 3 networks are connected directly. So the remote networks, one is here and one is here. Okay, one is with R1, one is with R3. Those are not directly connected to R2. They are remote network for R2. So R2 needs 2 static entries. 2, and R3 needs R3 would need 3 also. R3 has 2 networks directly connected, 3 are remote, so it needs 3 entries. Okay, so I was able to connect that as well. Okay, Innocent here, everything is going great. Thanks, Innocent, for the comment. Okay, wonderful. So you guys are watching. Okay, now test connectivity to the R2 and R3 LANs by pinging PC2, PC3 from PC1. Okay, I'm going to try to test connectivity to R2 and R3 LANs by pinging PC2 and PC3 from PC1. So I'm going to go to PC1. I'm going to try to ping to PC2 and PC3. So let's do that. PC1, here I am. I go always this way for my students, repeating many times the same thing and going very slowly. That's what I'm going to do. I'm in the PC1 desktop. I'm going to go to the command prompt. As I'm in the command prompt of PC1, I'm going to try to ping to PC2. And what is the PC2's address right here? In the addressing table, PC2 is 172.31.0.254. Okay. So ping, paste. Okay, it shows the destination host unreachable. Oh, so ping was not successful. Destination host unreachable. Oopsie, oopsie, oopsie. It could not reach. Okay, how about I try to ping it to PC3? PC3 is this one, 172 31.1.190. Ping. Okay, enter. Okay, same thing, destination host unreachable. So destination host could not be reached. Same way, so ping was not successful. So I'm going to go back here and answer this question. I mean the part one. Answer this question. Why were you unsuccessful? Because the routers do not know each other yet. The routers do not know the remote networks yet. Okay, a routing table has not been created. So because the static routes, because the routes, I would say this way, because the routes are not yet configured in the router. Okay, because the routes are not yet configured in the routers. That's why I got to configure the routes. The routers will know how to send this packet to a remote destination. Okay, so I'm moving on to part two. Part two says, step one, configure recursive static routes on R1. Recursive static route on R1. So I'm going to go to the R1 right here, and I'm going to configure a recursive route. Now, question number A here, what is recursive static route? Okay, now let me explain to you. What is a recursive route? Normally, do you remember when you are writing an entry in the routing table, you write the command IP route, then the destination network, then the subnet mask, and then the next hop router's address, or the exit interface, or both. Show you an example. Let me first go to the R1. Before I write the answer here, let me explain to you first. So I'm going to go to the R1. Go to R1 with me. Here I am in the R1. Okay. Enable mode. If I do show IP route, see the routing table right now. Okay. What does the routing table has? The routing table only has C, means directly connected. Only the directly connected networks are understood. That's it. Okay. Gigabit 00 and serial 000. Okay. Look at this routing entry right here. Look at this one particular routing entry. What does this mean? That will answer my question. That will help me explain to you. This this network 172.31.1.0 with a 25-bit mask, that network is directly connected. Directly connected, an exit interface to go into that network. My exit interface is gigabit Ethernet 00. So any packet, if sent to this network, if destined to this network, that packet has to go out via this exit interface. Okay. When I write a routing entry this way, this is called directly attached route because I'm specifying an exit interface. If I did not specify this exit interface, instead, I would write the next hop router's address. That would be a recursive route. Why? Because in that case, say instead of this one is going through gigabit 00 interface, right? We got that. Look at the picture. Now, if I say to another route, to this route, this network right here, 172.31.1.0. Okay, let us create this recursive route, and then I'll answer the question to explain to you better. Let me go ahead and create them. Then I'm going to tell you. Okay, configure recursive static routes on R1. Okay, So now configure a recursive static route to every network not directly connected to R1, including the WAN link between R2 and R3. Okay, so I'm going to do that now, and then it's going to help me answer this question, explain to you better. I really want to explain all the detail, in every detail. Okay, so let's configure it first. Okay, I am here. So let's go to the R1. Let's go to the config T, configure terminal. I'm in the config mode. Okay, I'm going to type IP route. That's the command. And what is the remote network that I have to do? Look at here. These two networks are directly connected. Okay, this serial 00. So this 130, 172, 31, 192 with 30-bit mask. That network is directly connected. That's already there. These two networks are already there. What are not there are the remote networks. One of them is here, 172.31.00 24-bit mask. Okay, 172.31.00, 172.31.0.0. Again, what network is that? This network. If you see my mouse, that's far away. That is connected to R2. That network. It's 24-bit mask. So I'm gonna write 255.255.255.0. Okay. Now, which interface does it go out? I'm not going to say that. I'm going to say what is the next hop router's address. So from R1, what is the next hop router's address? That is R2 right here. R2 serial 00, that interface, that's my next hop. So it's going to go through this serial port, go through this router right here. What is the IP address of this serial 00 on R2? Let's look it up. Serial 00 on R2. R2 serial 000. Its IP address is this, 172.31.1.193 and 255, 255, 255, 252. That's not my subnet mask. Let me let me write down that next hop. I don't need the subnet mask in this case, just the next hop router's address, 172.31.1.193. So I'm going to click on here. I'm going to do a paste. Okay, that's my next hop router. Enter. So now you see what I have just done. Now, so I'm going to explain what's a recursive route. Let me explain a little bit more now. Look at this line, compare with this line. For this network, I specified, or router did it automatically, a gigabit 00 exit interface. For this route right now, the one that I wrote, I did not specify the exit interface. I only specified a next hop router's IP address. That kind of route is called a recursive route. Okay, and I'll tell you what does the word recursive mean and why do we call it a recursive route. I'm coming into that. So let me configure two more remote network like that. So next line we're going to do this IP route again. One more network that I'm going to do. So this network so far, this one is done. 172.13.31.0. What is another network that's remote? Right here. 172.31.1. Can't read this one. Okay, 196. 172.31.1.196. And it's 30-bit mask. 172.31.1.196. Okay. 172.31.1.196. 30-bit mask. That's 255.255.255.252. That's 32-bit mask. So I did a destination network and subnet mask. And what is the next hop router? Again, to go to this route, to go to this network from R1, I still have to go through the R2, the same this IP interface. This next hop router is 172, this one, same one. So 172 dot 31.1.193. Okay, if you're confused why I'm using the same, again, look at, if I want to go to this network or this network or this network, any one of those, if I want to go from R1, look at the picture, from R1, I have to go through the same next hop route, same IP address here. That's why for all the remote network that I'm going, I have to go through this next hop, which is this same IP address right here, okay? R2's serial 000 interface. That's why I'm having to use the same IP address as a next hop. Enter. Another network, IP route, another remote network, IP route. This one would be right here. This 172.31.1128, 26-bit mask. Okay. So 172.31.1.128, and then 255.255.255.192. It's 26-bit mask. 26-bit mask should be 192. 0, then 128, then 1, yes. And the next hop would be the same, 172.31.1.193. So I configured 3 static routes. I just configured 3 static routes on the R1 router. And all 3 of them are recursive route. Now that I have done it, now you have seen it, now let me explain to you. What is a recursive route? A recursive route does not specify an exit interface, only specifies the next hop router. That is called a recursive route. Why is it called recursive? Because if router has to send data to this remote network, router is going to know that, okay, to go to that remote network, I have to go look for this next hop router. Then they would say, then the router is going to say, okay, I got it. I have to go to the next hop router. But second question is, how do I go to the next hop router? Where is that next hop router? With which interface do I go? What is my exit interface? Then it has to look up that how to go into that exit interface. That's why it has to work twice. First time, it goes to the routing table and finds out that I have to use this next hop router. Second question again comes, router again goes and looks for, okay, to go into this next hop router, which exit interface do I have to go out through? That's the recursive. That's why we call it recursive, because it looks up again. Okay. So now you understood what is the recursive. So let's write the answers now. Okay. What is recursive static route? A recursive static route is a route that only specifies the next hop router's IP. Not the exit interface, or not an exit interface. Okay, so recursive static route is a route that only specifies the next hop router's IP, not the, I would say not the exit interface, because it's only one exit interface that it has to go to there. Okay, now question B, why does a recursive static route requires 2 routing table lookups? Yes, that's why it is called recursive, because as I already explained, it's going to look up twice. We have to say once first it reads the table and finds the next hop router's IP. Second, it looks up how to, or looks up which interface, I would say, interface it has to exit in order to go to the next hop route. Okay, that's my answer. What I wrote is this. First, it reads the table and finds the next hop router's IP. Second, it looks up which interface it has to exit through in order to go to the next hop router. Okay, so that's my answer. So number C, configure it, which we already have done. Okay, which we already have done. And then test connectivity to R2 LAN and ping IP addresses PC2 and PC3. Were they unsuccessful? Oh, sorry, why were you unsuccessful? So now that we have configured this one router, let us try to ping. Okay, let's try to ping to the PC2 and PC3. So I'm gonna type. I can actually exit from here. Okay, I'm in the what mode? Privileged exit mode. From in this mode, I'm gonna type ping and PC2's IP. What is the PC2? PC2 172.31.0254. Paste, enter. Okay. And then we're gonna do from the go to the PC3 also and see if it works. I'm going to show you something here. Ping. It's very interesting. Sometimes the labs they gave you and they expect you to do something, it happens differently. Okay, now sending, let's see, success rate 0%. Yeah, that's PC3. There you go. Okay, for the PC, in this case, PC3 is far away. PC3 is right here. That's the way it should have been, all of them. PC3 is right here, and it was not able to ping. Why it was not able to ping? Because actually the R2 and R3 has not been configured yet. The routing has not been configured in R2 and R3. Okay, PC2 also should not have returned. PC2 also should not have returned. Okay, so but in this case, PC2 is just only one hop away. So it was able to do that. But PC3 is like 2 hops away. R1 has to go through R2 and then to R3 and then, so that's why it could not. So I will answer that it was not successful. So not to confuse you. In our case, really, with PC2 was successful. Okay, count it as not successful, like just like PC3. So why you unsuccessful? That is the question. Because routes in the router R1, R2, and R3 have not been configured. Okay, because R2 and R3 in those two routers, we have not configured the static routes yet. That's why. Now, going to step number 2. Going to step number 2, configure directly attached static routes on R2. Okay, so we already have done on R1. Now we're going to configure static routes on R2. How does a directly static route differ from a recursive static route? Directly attached static route, that is another type of static route. We already saw what a recursive route is. It specifies the next hop router's IP. And a directly attached static route would be different because it does not specify next hop router's IP. It only specifies the exit interface. That's how. So let's write the answer. A directly attached route, static route, only specifies the exit interface, not the next hop. Router's IP. That's why. So it only specifies the exit interface, not the next hop router's IP. Okay. Configure a directly attached static route from R2 to every network not directly connected. Now I have to do that in the R2. I'm going to go ahead and do that in the R2, but this time I'm going to specify the exit interfaces. So let's go to the R2. Here is my R2, and let's see in the R2 what are the remote networks. R2 already has 3 networks already connected. Which are 3? This 172.31.0.0, that is already with connected directly. 172.31.1.192, that is directly connected. 172.31.1.196, that is also directly connected. So R2 has 3 networks directly connected. So the only networks that I have to enter here that are remote, they would be this one right here, 172.31.10.25, and one right here, 172.31.11. These 2 networks, this one network right here, if you see my mouse, 172.31.11 and 172.31.10, this one. These are the 2 remote network. I have to configure them for in the R2. So let's do that. Enable, config T. So I'm in the global config mode. In here, I'm going to type command IP route. IP route. Okay. IP route, and which network? Let's do this one first. 172.31.10. 172.31.1.0. What is the subnet mask? 25-bit. So that is 255.255.255.128. Okay. And which exit interface do I take? So here I am in the R2, right? From the R2, I have to go this way. So what is my exit interface in the R2? Serial 000. That's how I go to the R1. So serial 000 interface is what I have to do. So S000. That's the interface. Okay. Enter. That's normal. It did good. Default route without gateway, if not a point-to-point interface, may impact performance. That's normal. You get that message. Then let's do one more. That is IP route. What is the other network? Is that one is right here. Is 172.31.1.128. One 128 and 26-bit mask. So 255.255.255.192. That's 26-bit mask. And what is the exit interface in this case from R2? Look at R2 right here. The exit interface is 001 to go this way. So this way towards R3. So S001. 001. Okay. Good. So I have done that. These two remote networks configured on R2. Now, which command only displays directly connected network? Okay. Am I in the right place? Okay. Yeah. Number C. Which command only displays directly connected networks? So let me show you the command. You know how to display a routing table. Show IP route. But if you use one more word with it, show IP route connected, then only the directly connected networks will show up. Okay, let me show you that first. Say I go to I'm in the R2 right now. Stay in the R2, fine. Okay, I'm going to exit from the global config mode. I'm in the privileged exit mode. In the privileged exit mode, I would like to first, I'm going to just show IP route. Show IP route. So it shows everything. It shows this C means directly connected. It shows this is static route. It's S, the one that I just did. Another S, the ones that I just did. L is the local network, local interface. Another C, directly connected. What if I want to see only the ones that are directly connected and nothing else? Okay, so I'm going to type this show IP route, that command, with one more word, that is connected. Tab, see, connected. Show IP route connected. That's the only thing. Enter. See, now what do I see? Only the C. C means connected. Only the three directly connected network. Remember, R2 has three directly connected network. One is this network right here with gigabit 00. Another is here, another is here. So we see these three are right here. Okay. So we say show IP route connected. That's the answer. Show IP route connected. Now, which command only displays, I'm in the question number D. Which command only displays the static routes listed in the routing table, okay? So I have to type show IP route static. Let's do that. Let me show you first. Show IP route and then static, static, static. Yeah. Now it's showing only this line starts with S, static. These are the two static routes I entered. Okay. So show IP route static. Okay. When reviewing an entire routing table, how can you distinguish between a directly attached static route and a directly connected network? Okay. So distinguish between a directly attached static route. Static route is going to start with S, okay, and a directly connected network. Okay. So one is going to start with S, one is going to start with C. Okay. Directly attached static route. starts with S, and directly connected network starts with C. There you go. Okay. And you can see it right here in this table. If you look at this table, that is true. Let me show you. Here something starts with S, these two. They are directly attached because they also are specifying that which interface to go out, exit interface, but they start with S. That's the difference. And the one that starts with C, that is directly connected. Okay? Like here, if I chose connected, only the C showed up. If I chose static, then only the S showed up. Okay? So you got that. Okay, so move on. Move on to the next. Okay. Step number 3. Configure a default route on R3. How does a default route differ from a regular static route? A default route. Okay. So how does a default route differ from a regular static route? A regular static route will show the path to a particular network, destination network. Okay. As opposed to a default route shows that any network that is unknown, that is there is no match found, those networks, for those destination networks, you go to a certain next hop router, okay, or an exit interface. So a regular static route static route shows the path for one specific destination network. Okay, so regular static route shows the path for one specific destination network. Okay, I would say path 4, I would say path 2. Path 2, one specific destination network. And the default route shows how to reach, or shows, I would say the same terminology I'm going to use, shows the path to all unknown networks. That's it. The default route shows the path to all unknown networks. Any network that you don't know, your router does not know how to go, just send it to that next hop router. That's going to be a default route. Default route is also called the gateway of last resort. Configure, question number B. Configure a default route on R3 so that every network not directly connected is reachable. So I'm going to configure a default route on R3. Okay, so one default route will cover all the networks, all the remote networks. Okay, so how do I do that? Let's go to the R3 and configure a default route. So here I am in the R2. I'm going to close the route, go to R3. So since I'm going to do a default route, I don't need to specify a particular route. Here I am, R3, enable config T. I'm in the global config mode. So I'm going to type, this is how I do a default route. IP route 0.0.0.0 space 0.0.0.0 space. Okay, so that means all routes in the world, not just one route, not just one network. all destination networks, not just one destination network, okay? How do I go? Look at R3 right here. R3 already has one network with its own. It doesn't have to worry about that one. But to go to any other network in the world, anywhere else in this site, R3 has to go to whom? Has to go this way. Or it has to exit through serial 001 interface. So any other network in the outside world, for those networks, R3 has to go exit through serial 001, okay? So I'm going to write that. Serial 001. Enter. That's my default gateway. Okay, default route. That's it. Okay. Now, if you want to see how it looks like the default route, I'm going to exit out of there, and I'm in the privileged exit mode. I'm going to say show IP route. See, this is your default route with a static S, because I manually wrote it down, but with an asterisk, with a star. Okay, it shows directly connected that. Okay, and it shows here gateway of last resort is 0000 network 0000. So gateway of last resort has been configured. Okay. How is a static route displayed in the routing table? A static route starts with an S. Also with the letter S. Okay, I'm in the step number 4. Document the commands for fully specified routes. Okay. Now, Packet Tracer does not currently support configuring fully specified static route. Therefore, in this step, document the configuration for fully specified routes. Okay. So, what is a fully specified route? Okay, well, remember 3 routes we have so far known, but I'm going to bring those 2 earlier ones. One was recursive, where we specified the next hop IP. Another was directly attached network, where we specified only the exit interface. What if you wrote a routing entry and there you specified an exit interface and a static route, exit interface and a next hop route, both? Okay, could you do that? Yes, we could do that. Okay, that will be a fully specified route. So a fully specified static route would have both the exit interface and the next hop. Okay, so explain a fully specified route. So I would say it specifies both and exit both the next hop router's IP and the exit interface. Okay. Okay. Now, which command provides a fully specified static route from R3 to the R2 LAN? The R2 LAN, what is the IP address of the R2 LAN? R2, here is its LAN, local area network for the R2 router. That is this one right here. 172.30.100.24. 172.30.100.24. So which command? The IP route 172.31.0.0. Okay, 31.0.0 and 24-bit mask 255, 255, 255, 0. Okay, and okay, next hop router would be R. I'm doing it from the R3. Okay, from the R3. So R3 is right here. From R3, so serial 001 interface right here. But make sure that you understand. Serial 001 interface of the R2. So serial 001 interface of the R2. Serial 001 interface of the R2. Serial 001. That is this one. 197. Control C. And the exit interface. Serial 001. Now, write a fully specified route from next question, question number C. Write a fully specified route from R3 to the network of between R2 and R1. Do not configure the route, just calculate it. Yes. Okay. I'm going to write similar command, IP route, and then from R3. Here's the R3. Between these two, what is the network address between the R2 and R1? R2, this is the network right here. 172.31.1.192. 172.31.1.192. 172.31.1.192. Okay, and then the subnet mask is 30-bit, which is 255.255.255.252. And what is the next hop router's address? Next hop router's address would be the same from R3. From R3 to go to R2, same one. That is 172.31. 172.31.1.197. Exit interface would be the same. S001. It has to go through the same path to go there. Write a fully specified static route from R3 to the R1 LAN. Do not configure. Same thing. Same way I have to go. Same way I have to go to the R1. But I'm going to, of course, write the R1's LAN's IP address. Control C, Control V. On this one, it has to go through the same path, but which direction I'm going? Where am I going? Going to this LAN right here. 172.31.10. 172.31.10. So let's write that. 10 to this LAN. That's the R1's LAN. And it's 25-bit mask. 25-bit mask will be 255, 255, 255, 128. That. Okay. And then it tells me now, verify static route configurations. Use the appropriate show commands to verify correct configurations. Which show commands can you use to verify the static routes, or verify that the static routes are configured correctly? Okay, so I'm going to say show IP route static. That's the command. Okay. Now last part 3, the very last one, verify connectivity. Every device should be able to ping every other device. If not, review, then we have done something wrong. So let's see. If I go to the PC1, I should be able to now connect all the way, ping all the way to PC2 and PC3, the very end-to-end connectivity. Let's check that out. I'm going to go to the PC1. Here I am in the PC1. Okay, again, those of you who didn't know how to get there, you have to go to the PC1, go to the command prompt, okay, and type ping to PC2. PC2 is this 254, this one, 172.31. Okay, here I am. Now I should be able to reply. Yes, now I got the reply. Destination is not unreachable anymore. How about the PC3? PC3 would be 172.31.1.190. 1.190. Oopsie. First request timed out, but then again I got the reply. I do one more time and we get all the reply properly. So we have verified. So our lab is done. So my friends, so this lab is done. Now remember, for this lab, I want you to submit both the PKA file. Make sure you save this file. Go to File, Save As, okay, and save this file, PKA file, to wherever you want to save. And routes, okay, I could save to my flash drive, for example. Sources. Okay, I can do that. And then this file, my friends, now pay good attention to this one. Some of you will do mistakes. This file, as you know, the PDF file you cannot save. You can only print, okay? So follow me right here. I click on the print, save as PDF. When I choose the printer, which printer do I select? Save as PDF, that's my printer. Then click on save. And then save in the same place. And with the same name, whatever name you want to put, whatever name comes up, just write your name on that as well. And click on save. Okay. Now you upload both files. To get credit for this lab, I want you to upload the packet tracer file, the PKA. I also want you to upload the PDF file. Okay. That concludes our lab. If you have any question, anything, do you mind re-explaining the different static routes? Okay, I will explain to you one more time the different types of static routes. There is one static route that is called the recursive route. On that route, you only specify the next hop router's IP address, not the exit interface. That's number one. Number two, another type of static route is called the directly connected static route. Directly attached, not directly attached static route. On that, you specify just the exit interface for the destination network. Just the exit interface, not the next hop router. Number three, another type is called fully specified static routes. And that is where you are specifying both an exit interface and the next hop router's IP address. You write down both on the same line when you configure the route. That is the fully specified static route. Again, specifying exit interface and next hop router's IP. Number four is the default routes. A default route we already understood. We write with 0000 with a mask 0000. That means all the networks in the world that you need to go via this exit interface. Okay, so that's about it. So my friends, I hope that helps. And let's see, if I have right now, I need to write host only. Okay, so once I see this screen comes up, then I will know that we have reached the end of it, and I'm gonna end the stream. Okay, so I hope that, by the way, wait, tonight I'm gonna again come back after some time, maybe half an hour, so say 12:30, say around 12:30, 12:40, about that time I'm coming back for the chapter 3, my friend. I'll do the chapter 3 and then I'm gonna do the lab. So both are important. Having chapter 3 and lab, we got to do both. So today is my long classes per se. I'm gonna work harder today. So come back in another half an hour. Maybe come back at 1 o'clock. Come back at 1 o'clock for the lab, for the chapter 3. Okay, come back at 1 o'clock for chapter 3. Let's see where. Okay, now